Hey guys, what's up? So this is Ujjwal Kumar Sen and you are watching Ujjwal Kumar Sen YouTube channel. So guys, आज के वीडियो में बात करने वाले हैं मोस्ट इंपोर्टेंट फार्मूलाज ऑफ RAC मतलब रेफ्रिजरेशन एंड एयर कंडीशनिंग। किस एग्जामिनेशन के लिए डेडिकेट कर रहा हूँ वीडियो को? यूपीपीएससी एई के लिए। लेकिन ये अगर आप पढ़ाई कर रहे हैं एसएससी जेई का प्रिपरेशन कर रहे हो या फिर कोई पीएससी का प्रिपरेशन कर रहे हो या फिर गेट कर रहे हो, हर जगह ये फॉर्मूलाज काम आएगा। तो सबसे पहले आपको, हालांकि हमारा सबका टेस्ट सीरीज है लेकिन बिकॉज मैं इस वीडियो को डेडिकेट कर रहा हूँ यूपीपीएससी एई के लिए, सो यूपीपीएससी एई का मैकेनिकल टेस्ट सीरीज हमारा लॉन्च हो चुका है, राइट। और इसका प्राइस सिर्फ क्या है, 499 रुपीज है। और इसमें हम क्या क्या आपको दे रहे हैं, ये 10 टेस्ट सीरीज आपको मिलेगा, पेपर 1 का 5, पेपर 2 का 5, फुल लेंथ टेस्ट सीरीज, राइट। और इसमें जो इंटरफेस हमारा जैसे एग्जाम जैसा होता है, आप देख सकते हैं जैसे एग्जाम में मिलता है वैसा इंटरफेस है, राइट। सो आप जरूर ग्रैब करें इस टेस्ट सीरीज को और टेस्ट सीरीज जरूर दीजिए। 10 टेस्ट सीरीज आपको देना है फॉर बेटर प्रिपरेशन और अपने आप को जज करने के लिए आपका प्रिपरेशन कैसे चल रहा है। प्राइस कितना है? 499। लिंक कहाँ मिल जाएगा आपको? फर्स्ट कमेंट में एंड डिस्क्रिप्शन में, सो दैट आप इजीली ग्रैब कर पाए। अब चलें गाइस मेरे आईपैड पर और हम देखेंगे अब सारे इंपॉर्टेंट फॉर्मूलाज फॉर आरएसी। थैंक यू वेरी मच फॉर watching the first part. Now let's go for it.
So list of important formulas of RAC for gate, right? RAC means, you know, I hope, refrigeration and air conditioning, right? So first we'll start from what? Heat pump. First we'll start from heat pump, right? Guys, I'm not going to share with you definition because it will take then a lot of time, because RAC itself around 25 hours lecture class, 25 hours to 30 hours. Even if you're preparing for ESC, then definitely it will be more, because there are so many topics we need to cover, those we do not cover in case of gate. So COP of heat pump, right? We have two formulas basically, QH by QH minus QL is equal to QH by WL. So this is in terms of what? Heat. Now let's talk about temperature one. So COP of heat pump is equal to TH by TH minus TL, right? Now most important thing you need to remember here for what is that, if they have given in the problem heat as well as temperature, all the terms, I mean TH, TL, QH and WL, then you need to use heat one to find out COP of the heat pump as well as for the refrigerator. I mean this thing will be applicable for refrigerator also. Now second is what? Refrigerator, right? So what is refrigerator? You know that. Now let's go for it. COP of refrigerator is equal to what is that? QL by QH minus QL, right? So there is little difference between refrigerator and heat pump. So this is for heat. Now let's come to temperature. COP of refrigerator is equal to TL by TH minus TL. Got it? This is the case of refrigerator. Now let's come to what? Their relationship. So 1 plus COP of refrigerator is equal to COP of heat pump. Now let's come to COP of refrigerator, COP of heat pump and efficiency of heat engine, their relationship. 1 plus COP of refrigerator is equal to COP of heat pump is equal to 1 by efficiency of heat engine. Now let's talk about efficiency of heat engine. It will be like this: T1 minus T2 by T1, right? This one is the higher temperature, this one is the lower temperature. I hope you got it. Let's come to VCRS, vapor compression or cycle refrigeration system, right? Okay, now you need to remember TS diagram, right, which is really important. So COP of VCRS, okay, let me write properly. VCRS is equal to H1 minus H4 by H2 minus H1. Now let's come to the seventh number formula, which is, I hope, pretty important for you, right? So here we're going to talk about what? Refrigerants, right? Okay, so there are two types of refrigerants. One is primary, another one is secondary, right? Okay, now before going to any other thing, let me share with you about primary refrigerants. So primary refrigerants are here: R11, R12, R22, all these are primary refrigerants. Now let's come to secondary refrigerants. Those are water, brine, NaCl solution, you can say that, right? Okay, now let's come to formulas. Those are really important. So what is the heading of this? So till now we have done 9. 10th number, designation of refrigerant, right? So what is the designation of refrigerant? Now here first we'll study about what? Saturated hydrocarbon. Saturated hydrocarbon. In that case you need to remember three formulas, right? Three formulas, right? So what are those? Are m minus 1, n plus 1, and then p. Now n plus p plus q is equal to 2m plus 2 CmHn FpClQ. Now maybe you're thinking how we can able to implement all these formulas. I can easily understand that, right? Now let me share with an example. Okay, as I have already shared with you, this lesson will be little bit lengthier, right? Okay, let's say we wanted to find out chemical constituents of what? R22. Now we need to write it like I am writing here, R022. Now compare this equation with this one, that is R m minus 1 n plus 1 p. So here m minus 1 is equal to what? 0, right? So what we can say, that m is equal to 1. N plus 1 is equal to what? 2. So what we can say, that n is equal to 1 and p is equal to obviously q. So compare like this, right? Like this. So yeah, this one is for p and this one, that one is for n plus 1. Now put all these values m and p in the equation, that is what? N plus p plus q is equal to 2m plus 2. Got it? So n is what? 1, p is 2. You need to find out q. 2 into 1 plus 2. So 2 and 2 will cancel. Q is equal to 2 minus 1 is equal to 1. Now put all the values in this equation. I mean in this you can say that what? In this formula or equation, whatever you wanted to say. Cm means C1. Hn, n is 1. P means 2, and Clq 1. So you can write 1 or not, it is on you. So this is the chemical constituents of what? R22. Like this way you can find out all the important or you can easily find out if they are asking. Even I am sharing with you ready-made formulas for you. That's why you can easily mark the answer. You don't need to go through further calculation. So R11 CFCl3, R12 CF2Cl2, R22 CF, sorry, H, I am missing H1, that is CHF2Cl. Now let's go for the bigger one, R134 C2H2F4, right? And this R134 is known as what? Eco-friendly refrigerant. Got it? So this is the this is the case for what? Saturated hydrocarbon. Let's come to the unsaturated hydrocarbon, right? So 11 number, unsaturated hydrocarbon, right? Okay, So in this case, again we are having three formulas, A, B and C, and already I have shared with you how to implement, right? So you can try and implement. So R1 m minus 1 n plus 1 p, n plus p plus q is equal to 2m, and the last one is same, CmHn FpClQ. So these are the formulas you need to implement for saturated hydrocarbon. Now let's come to inorganic compound. I will share with you a trick here, right? I will share with you a trick here. Inorganic compound, right? Okay, so in case of inorganic compound, so R value would be 700 plus molecular weight, right? Now let me share with you a few ready-made refrigerant formulas, right? CO2 would be R744, SO2 will be R764, and H2O will be R718, NH3 will be R717, argon will be 729, right? So these are the ready-made formulas for you. That's why you will not face any problem. Now let me share with you few more important formulas. Those are really important. So far we have done 12 formulas, right? I'm going to share with you enthalpies at various points as well as entropies at various points, right? This is also important in order to find out questions if they are involving with dryness friction, right? Enthalpy at various points. So let's take an example, this one, TS diagram. So just we need to draw this diagram, right? Here A, here B, here C, here D, and here E. Okay, now for this point, what we can say that this is saturated liquid, you can say that, right? So HB is equal to what? HF. So at this point, saturated vapor, HD is equal to HG. Got it? So for these 2 points, you don't need to do anything else special. Now let's come to HC. HC here. So here we got what? Wet region, right? Okay. So what we can say that the formula would be HB, that means HF plus XHFG. And you know HFG is equal to Hg minus Hf. Got it? Because Hg is greater than Hf, right? Enthalpy of gas is greater than enthalpy of liquid. That's why it is saying. Now what we have done, okay, now HC we done. He, so for this point we need to find out, right? He saturated, you can see the saturated condition here we need to find out, right? He is what? HD plus Cp Te minus Td. Now let's come to the last one. Ha is equal to Hb minus Cp Tb minus Ta, right? Okay, Ta. So these are formulas for what? Enthalpies at various points. Now maybe you're thinking why I'm sharing with you, okay, all that, but because this is important, that's why I'm sharing with you, right? Now let's come to the 14th number, that is what? Entropies at various points, right? These are also important. So let's talk about entropies at various points. So first we need to draw a simple graph, TS diagram, you can say that, right? Okay, so here we have done A, B, C, D, E. Again, SB is equal to SF, SD is equal to SG. Got it? Now let's come to SC. SC is equal to SB plus X SFG. This can be written like this: X SG minus SF. Got it? So this one, and this one. Let's come to what? SE. SE is equal to SD plus Cp vapor, that will be for vapor, natural log, Te by Td. and SA SB minus CP, and this will be for liquid, natural log TB by TA. I know remembering all the formulas just by watching these videos is really difficult, right? So what you have to do, you have to keep solving numerical problem. Now let's come to the important one which may be useful for you, that is what? Dryness fraction, right? Which we have already used, that is X. So it is denoted by X. S is equal to what? mv, mass of vapor, right? And then mass of vapor plus mass of liquid. So you can say like this. So you can say like this. It may be defined as the ratio of mass of vapor to the total mass of mixture, right? And its value lies in between 0 to 1. Got it? Now let's come to the 16th number. What? 16th number formula. So that is not the formula, but I will share with you most important thing which will be useful in case of solving numerical problem. So cascade refrigeration system, cascade refrigeration system. When we need to use this refrigeration system? To get the COP of the combined cycle when two refrigerators are operating in series. Got it? So in that case, COP of the combined cycle is equal to COP of 1 multiple COP of 2 division 1 plus COP of 1 plus 1 plus COP 2, right? So this is important, that's why I'm sharing with you. Even in GATE they have asked question from this topic couple of times, that's why I am sharing with you guys. Got it? I hope you are getting me. Now let's come to what? VARS, right? What is that? VRS means vapor absorption refrigeration system. I hope you have watched my videos related to it. Guys, if you are facing problem with any topic, if you want to learn from little bit basic, just like a crash course, then you can see the first comment even in the description. I have shared there a link and you can watch those videos in Hindi also, right? Okay. Now let's come to what? COP of VARS, vapor absorption refrigeration system. Now let me share with you four important points, right? Four, five important points, right? Here in case of VARS, what we do? We you can say that solar absorption refrigeration system, right? It is working on this principle. Most important thing is that. Next, VARS system is runs on low grade energy, right? And most commonly used refrigerant absorber pair are NH3H2O, then lithium bromide and water. And here we are replacing compressor with three important components: pump, generator, and you can say that absorber. So three important components we are using in place of what? Compressor. And most important four again most important topics I would like to share with you. Information basically: analyzer is working for dehydration, receiver is working for storage of high pressure liquid, generator removal of vapor from strong aqua solution, and rectifier producing dry ammonia vapor by removing water particles, right? Okay, now let's go for the what? COP of this. So here we're going TZ, T0 and TE. Just consider this as engine and this one we need to consider as refrigerator. Both you just need to multiply, you will get the answer. So for engine, what we can write basically, if you know, 1 minus T0 by TZ, right? Because TZ is greater than T0. And for refrigerator TE, T0 minus TE. Now let's combine these together. So TE by TZ multiple TZ minus T0 by T0 minus TE. We can write like this. I have written here. So this is the COP of what? VARS, right? Now let's talk about another refrigerator. So 17 number, right? Okay, so 15, 16, 17. Now 18 number, let's come to 18. That is what? Electrolux refrigerator. I know this video is going a little bit lengthy, but yes, let me share with you guys, this video will be quite fruitful for you. The main aim for this refrigerator is to eliminate noise, right? For noiseless operation, we use this refrigerator. And in this refrigerator, we use three fluid system, right? Three fluid, you can say that. Those are NH3, first, second, H2O, and third, H2. Here NH3 is working as what? Refrigerator. H2 is working as what? Absorber. And H2 is used to create low pressure of NH3. Low pressure of NH3. Got it? So this is all about what? Electrolux refrigerator. Now we'll talk about what? Next one, 1819. Reversed Brayton cycle, or you can say that Bell-Coleman cycle, or you can say that ideal refrigeration cycle. Even you can say that ideal refrigeration cycle, right? Okay, now let's talk about COP. COP of reverse Brayton cycle is equal to 1 division, right? Okay, just do one thing. Yeah, 1 division RP to the power gamma minus 1 by gamma minus 1, right? So this is the formula for what? COP of reversed Brayton cycle. So till now we have done lot of formulas. Now we need to do few more. 20th. Now we're talking about what? Psychometry. And in case of psychometry, there are two important things. Those are what? Omega. Omega means what? Specific humidity. Specific humidity. It is also known as humidity ratio. This is a dimensionless quantity, and its definition, or you can say its formula, are here. Omega is equal to mv by ma is equal to 0.622 into pv by p minus pv. Now maybe you are thinking what is pv and all that. Okay, so here p is equal to pv plus pa. Now what is p? P is what? Total pressure. If it is not given, then we can consider it as atmospheric pressure, which is 1.01325 bar. Okay, now what is PV? Basically partial pressure of vapor. This PA1, partial pressure of air, right? Okay, so this is a dimensionless quantity, mass by mass, right? Are you getting me? Now let's come to 21st number formula. That is what we're talking about. Phi. Phi is what? Relative humidity, right? Its formula is here. Phi is equal to mv by mvs is equal to pv by pvs. What is basically mv? So you can the formula, that is mv is what? Mass of vapor under saturated condition, right? Okay, now let's come to the next point. That is what we talk about: relation between dry bulb temperature, wet bulb temperature, and wet bulb depression, as well as dew point temperature. So let me share with you what is wet bulb depression. Wet bulb depression is equal to dry bulb temperature minus wet bulb temperature. Now let's come to 23rd. In case of unsaturated air, what is going on? Basically dVT is greater than WBT is greater than dPT. Is dPT means dew point temperature. Now let's talk about what will be happening in case of saturated air. Dry bulb temperature is equal to wet bulb temperature is equal to dew point temperature is equal to 100% relative humidity. Got it? Okay, now what will then in this case, what will happen for wet bulb depression? WBD is equal to dry bulb temperature minus wet bulb temperature is equal to 0, because both are equal, right? Now let's talk about few more formulas. Those will be useful, right? And which psychometer we use for measuring dry bulb temperature and wet bulb temperature? That is sling psychrometer, right? Remember this, sling psychrometer. Now let's talk about what? Degree of saturation. DEGREE, degree of saturation. This is denoted by what? Mu. Mu is equal to W by WS is equal to PV by PVS, P minus PVS division P minus PV. It could be written like this: phi P minus PVS P minus PV, right? This is important one, right? Okay. Now let's come to what? 27th number. Enthalpy of moist air. We want to find out enthalpy of moist air. If you want to find out enthalpy of moist air, that is what? H moist air 1.005 T. What is T? Dry bulb temperature, and to be taken in degree centigrade, plus omega 2500 plus 1.88 T. So always try to remember this formula, right? Okay. And its unit would be what? That is interesting. Kilojoule per kg of dry air. Okay. Now let's come to what? Last one, that is what? F-John formula. F-John formula. In this formula, PV is equal to PV dash minus 1.8 T minus T dash, right? Division 2700. Okay. Now maybe you're thinking, what is PV? What is PV dash? What is T and what is T dash? T already what? I have already shared with you, dry bulb temperature. Now T dash is what? Wet bulb temperature. Now let's come to the next one. That is what? That is a PV dash. PV dash is what? Saturation pressure corresponding to the wet bulb temperature, and P is what? Total pressure. Now as I have already shared with you, that if total pressure is not provided, then what we can do, right? We need to consider atmospheric pressure as total pressure. Got it? So guys, I hope you learned something from this tutorial, right? And most important thing is that if you are facing problem in any topic, or you wanted to learn from basic, you can check out in the below first comment, or even in the description, to get all information related to RAC and to watch all the tutorials, right? So let me know guys, what do you think about these lessons?